This video covers how to do power analyses in the Power tab. From the Power tab, scroll down towards the lower half and go to the section under Power Analysis using a two-sample binomial proportion test or a one or two sample t-test. There are preset values here to demonstrate a power analysis, and the results are below. We'll start with the results. We generally have about 4 types of information that will give us estimates for the amount of power and the sample size required for that power. When running a power analysis, we often have just 3 of those values. This is generally done before a study is conducted. Any of these values that are calculated after data has been collected and results have been analyzed are called post hoc power analyses, and fundamentally they have less power or less meaning than if you were to assign these values prior to the study. We may have gotten that level of power just by our data collection, so that's why post hoc power analyses don't have the same impact as the power analyses that are conducted before a study starts. And the reason that we'd want to do that before the study starts is that we'd want to conduct a study in which we'd consider that our results didn't happen just by chance, and that is what defines power in a power analysis. So the 4 bits of information that we consider in a power analysis are the sample size, the rates or the expected or the values for our different groups. In this case, the proportion for group 1 we're anticipating at 0.15, and the proportion for group 2 we anticipate it will be 0.3. We also define a significance level or an alpha level. This tells us at what level are we willing to accept that there may be an error. So the standard is 0.05, and we also consider the power level, and that's the level of power that we expect or that we anticipate. And this is what we're shooting for. So if we have an 80% power, a good way to think of that is that if we were to conduct the study 100 times, then we'd expect to see the kind of results we got about 80 out of that 100 times. So a standard level of power is 0.80 or 80%. So what we often do if we're looking for the amount of, if we're trying to calculate power, then we would need values or estimates for the sample size, the proportions for our 2 groups, and the significance level. Conversely, if we want to know how big of a sample do we need to collect to have a certain level of power based on our alpha or significance level, and the expected values that we would see, we would use those values to then calculate how big of a sample size we need. And both of these concepts work in when we have a binary outcome or a continuous outcome. So if we're doing a proportion test or a t-test. So you can see these values here, and under continuous outcomes what we are seeing are the sample size values. Now if we change it to power, we would see what power level we have. And similarly, because all these values are entered in there, they're going to show up within these tables. But if you wanted to do a proportion test and you wanted to look at how big of a sample size or power that you had, because we want to determine power, we're going to leave that blank and scroll down, and we get that value of 0.72. So based on these two proportions of 0.15 and 0.30, using an alpha or significance level of 0.05, which is a standard value, and using a two-sided test with the sample size of 100 per each of the two groups, so a grand total of 200, we would see that would give us, based on those differences, where group 2 has a value twice the size of group 1, seeing results like that would give us 72.2% power. Because many of these tests are impacted by the size of our sample, with very large data, it's very easy to get a high level of power and to see significant values just because sample size is part of many equations. We can also consider effect sizes, and effect sizes kind of give us an idea of what is a big, small, or medium size effect. And we have these different ranges here. So with these, on our binary outcome, we had an effect size of about 0.36, and that's slightly larger than a small size effect, and we would just default to that, calling this a small size effect. We would need bigger differences between our groups before we'd say it's a medium or even a large size effect. So this is how to conduct power analyses with continuous and binary outcomes. And this can be done in the Power tab